So, hi everyone, my name is Tim and I'm here on behalf of the University of Freiburg, especially the Innertech Institute, I think it's somewhere there. And for all the people who know Mirko Schäfer, and this is somehow his baby, but I'm presenting it because I was in the background more or less developing it. And what we did, we launched, I think last week, a web page which has like historic and current CO2 emissions on a regionalized level for Germany. So this is new. In case of like electricity maps, I think they have it just on like an aggregated German level, but we regionalize it. And the question is now, how did we do that? And I want to guide you quickly through it. And if there are any questions, you can come later on and we can discuss. We basically have 5 steps and then one secret model in the middle, which becomes open source like soon. We just like, there's everything already on the web page, but we just like will make it open soon. And we have like these 5 pillars. The first pillar is like generation and demand. We somehow need the data, then we regionalize it, and we do some stuff with renewables, and then we basically throw everything in our model and get out a nowcast. So what's the state now? And from that, we use machine learning to forecast it. That's still ongoing. So I guide you through that. So here we have ENSO-E data, which is aggregated on German or on like country level basis. So this is great, open data per unit, per type, but we somehow need to disaggregate it. So we need to regionalize it. For that, we can go in there and say, okay, we have load regionalization from the Fraunhofer Institute. We could also do the static, but this one is better. And we have the Marktstammdatenregister for Germany, which is like a database of 5 million power plants, in particularly renewables and like conventionals, but renewables are more. And then we distribute the generation per type over Germany based off how much of like these units are in a certain federal state. Basically also possible on NUTS 3 level, but we do it now for like federal states. So the next point is renewables itself. We can do them better than just like disaggregating this overall German profile. For that, we use AdLight to calculate historic like profiles, generation profiles on grid cells over Germany in a more or less high resolution. The problem with AdLight is, or with historic era 5 data, it's just till -5 days or 1 week. So, but we want to have it now. So what we did there is, or what I did there, and that's why it's in a green box, that's my part, or one part, we integrated renewable forecasting tools into AdLight, so basically a new data set which comes from the DVD or from openmod web page. So this allows us to basically predict or get a time series which is until now or even 10 days in the future. And from that we can really say, okay, now we have our web page, we can say, okay, what are the CO2 emissions in our electricity grid in a certain federal region for now and the past. And one thing I forgot, what is here in the background of this model? It's like a pipes network with a different objective function. So we basically embedded this in the whole European context where each other countries are single nodes and we calculate the flows. So we changed the objective function to be a flow minimization, which turns then out to better represent like the flows between the federal states, more or less. Yeah, and what's coming now, it's the forecast. As you can see, this is for the German level already, and it's quite close, so it's actually quite okay. We are open for help for doing this for the regionalized level, but I think we will also figure some ways out. So check out the webpage. Thank you for the attention.